the Milky Way. In this assignment, we will see how we use different filters to identify features in the Milky Way. Basically, we have two filters, filter E for red, filter O for blue. If we use filter E, everything we see is in red, but these are in negatives. So strong red will be black, light red will be gray, and if it's not red, you won't see this feature in filter E. For filter O, we have blue. Strong blue will be black, light blue will be gray, and if it's not blue, you won't see it. Let's say this is one region in the sky. This is region 1099, and we have filter E in top, filter O in the bottom. If we compare, you can see there is a cloud, kind of gray cloud in filter E, top one, but you don't see this cloud in the bottom one. So this cloud is red. If we compare stars, for example, take star number 4, we can see it's much bigger in filter O compared to filter E. So this star is blue. This is another example. This is region 754. Top is filter E red, bottom is filter O blue. And again, you see big clouds in filter E. So these clouds are red because we can't see these clouds in filter O, bottom one. What are these important features? We have emission features. They emit the light and they will be black in negative images. And we have absorption features. They absorb the light, they block the light, so they will be white in negative pictures. For emission features, we have H2 clouds. These are very big and they are red. So for example, here, these red regions are H2 clouds. These are all in filter E. You can't see H2 regions in filter O because they are red, but they are usually big. Other features are planetary nebula and reflection nebula. Planetary nebulas are very small and red, and reflection nebulas are very small and blue. So they both are very small, but the main difference is planetary nebulas are red, you will see in filter E. Reflection nebulas are blue, you will see in filter O. So for example, this is very small feature in one of the pictures, and if we zoom, we see it's visible in one filter and invisible in the other one. Depending on the color, it will be either planetary nebula or reflection nebula. Moving to absorption features, we have globules. They are extremely small pixel size in your image, and we won't discuss globules. But dust features are very big, and because they block the light, they will look like white. So these red regions are all dust. Basically, they are in front of H2 regions, so they block the light, and that's the main reason we see all dust regions are white. We can also compare H2 regions and uh, find out their age without any calculation. So because they tend to spread away, larger means they are older, and after a while, their edges will be just spread away. Their edge is not well defined. They are not as dark as young ones. So for example, if you compare A and B, in this case, B is larger, it doesn't have very well defined edges, and it's grayish compared to A. So B is much older than A in this case. We can also compare their distances. For distance, if we assume there are uniform number of stars in our galaxy, so further they are, we have more stars in between. So we will see more stars in front of this H2 cloud. So if we see more stars, it means they are further away. If we see less number of stars, it means they are closer. For this purpose, because they have different size, you better pick a same patch in both of them. Very close to dust area is better, and then compare number of stars.